In this video, we will learn about the builder design pattern and how to implement it using C++ code. Builder is a creational design pattern, meaning it facilitates the creation of objects. It allows us to create complex objects step by step. Unlike other creational patterns, products don't need to have a common interface with Builder, so the same construction process can be used to create different products. Let's take a look at a conceptual example to understand the process before jumping into the code. If we want to write code that can create burgers, we don't want to hard code the recipe for a specific burger. We may want to use different ingredients on the burgers we create, but use the same creation code and not have to rewrite the bulk of the code each time we want a new type of burger. At a high level, our program will consist of four main parts: a burger class, an abstract builder class, a burger builder class that implements the abstract builder class, and a director class that will contain the recipes for making different types of burgers, using the burger builder class. Now that we have a conceptual understanding of the builder design pattern, we will learn how to implement it using C++ code. Let's create some enums for the different types of things a burger can have on it. We will have an enum named meat type that has the possible values rare, medium rare, and well done. Then we will have an enum named cheese type that has the potential values American, Swiss, and non-dairy. We will also have an enum named condiment type with the potential values ketchup, mayo, and mustard. After that, we will create our burger class. It will have the following public attributes: an attribute of type meat type named meat, an attribute of type cheese type named cheese, an attribute of type bool named lettuce, an attribute of type bool named tomato, and an attribute of type condiment type named condiment. After that, we will create a class named builder, which will have several public functions. Let's add a virtual void function named addMeat that takes in one parameter of type meat type named meat type. Then we will have a virtual void function named addCheese that takes in a parameter of type cheese type named cheese type. After that, we will create a virtual function with a void return type named addLettuce. Then we will create a virtual void function named addTomato. Next, we will create a virtual void function named addCondiment that takes in one parameter of type condiment type named condiment type. After that will come a virtual void function named printBurgerInfo. Next, we will create a class named burgerBuilder that extends the builder class. Inside of here, we will use the public access modifier and have a variable of type burger named burger. Then we will add a constructor for our burger builder class. After that, we will override the addMeat function, and inside of here we will set burger.meat equal to meat type. Then we will override the addCheese function. Inside of this function, we will set burger.cheese equal to cheese type. Next, we will override the burger class's addLettuce function, and inside of here we will set burger.lettuce equal to true. Then we will override the builder class's addTomato function, and inside of it we will set burger.tomato to true. After that, we will override the addCondiment function, which takes in one parameter of type condiment type named condiment type. Inside of this function, we will set burger.condiment equal to condiment type. Next up, we will override the printBurgerInfo function. Inside of this function, we will output the meat, cheese, lettuce, tomato, and condiment to the console, with each line getting indented with a tab at the beginning, and ending with a new line character. Let's create the director class next. It will have two public functions. The first will be a function with a void return type named makeRegularBurger that takes in one parameter of type builder named builder. Inside of this function, we will have a variable of type meat type named meat type that we set to medium rare. Then we will have a variable of type cheese type named cheese type that we set to American. After that, we will have a variable of type condiment type named condiment type that we set equal to ketchup. Then we will call the builder's addMeat function and pass in meat type, addCheese function and pass in cheese type, addLettuce function, addTomato function, addCondiment function, and pass in condiment type, and finally call the printBurgerInfo function. The second function in our director class will be responsible for making a different variation of burger, a Krabby Patty. We will have a function with a void return type named makeKrabbyPatty that takes in one parameter of type builder named builder. Inside of this function we will have a meat type of well done, a cheese type of American, and a condiment type of mustard. Then we will call the builder class's addMeat function and pass in meat type, addCheese function and pass in cheese type, addLettuce function, addTomato function, addCondiment function and pass in condiment type, and then call the printBurgerInfo function. Time to test our code. Inside of C++'s main function, we will create a variable of type director named director. Then we will have a variable of type burgerBuilder named burgerBuilder. After that, we will output the string making a regular burger to the console, followed by a new line. Next, we will call the director object's makeRegularBurger function and pass in burgerBuilder. Then we will output the string making a Krabby Patty to the console, and then a new line. Finally, we will call the director object's makeKrabbyPatty function and pass in burgerBuilder. When we run the code, notice that the attributes of the regular burger and Krabby Patty were output to the console, meaning the builder pattern we implemented successfully created the burgers that we specified with the ingredients that compose them. You may be asking yourself when you would use the builder pattern in the real world. Have you ever run into a situation where you have many constructors for an object? For example, using the builder pattern makes the code cleaner than having our burger class have many constructors with different parameters. We would also use the builder pattern where we want our code to create different representations of a product. For example, regular burgers and Krabby Patties are both types of burgers. The burger pattern is also useful when creating complex objects. Advantages of the builder design pattern are that it allows you to create objects step by step. You can reuse the same construction code when creating different variations of objects. And it follows the single responsibility principle, where each piece of code performs a single task and not multiple tasks. The responsibility of each individual class and function is clear. In terms of disadvantages, the builder pattern increases the complexity of the code, since this pattern involves creating several new classes.